1.2, go ahead and start copying this down, but 1.2 starts us with some definitions. So the idea is that you need to know what a variable is, okay? Well, a variable, literally, you can go to the meaning of the word. It's something that varies. A variable, it varies. It changes. In mathematics, we use a symbol for that. An X, Y, Z, it stands for some number we don't know. It varies. I heard an example of somebody that was, like a child who'd learned algebra for the first time, basic, and they solved for X and got like X was 5. They're like, cool, X is 5. I'll memorize that and X will always be 5. They didn't understand that X is a variable. It changes. On the different situations, we use that letter, that symbol, for some number we don't know. And depending on the question, it will vary. It will change. That's why we call it a variable. Versus a constant. A constant means something stays the same. I hate my handwriting here. Let me fix that real quick. So like 5. 5 is always 5. If I have 5 of something, you have 5 of that. 5 is constant. That means that any number, no variable, no x, y, z, any number is constant. Okay? As long as it's just that number by itself. Now, if I have 5x, that changes things. What's an expression? Well, that's when we mix variables and constants. We blend the variables and constants together and we get an expression. That's through addition, multiplication, all of those order of operations. When we blend them together, we get what's called an expression. So that would be something like x plus 2. That would be something like 2x, because that's 2 times x, right? What's an equation? Well, it's a variable and constants, but at the end we get this equal sign. This equal sign, that's supposed to be an arrow, this equal sign makes it an equation. Equation literally has equa in front of it, right? As in the same root as equal. When we have an expression, we're just expressing some mathematical group. When we have an equation, we are equating it. We are making it equal to something. So instead of just x plus 2, it would be like x plus 2 equals something. Instead of just 2x, it would be 2x equals something. So the minute you set that expression equal to something, that becomes an equation. Here's some examples of expressions. 3m. 3m is an expression. It has a constant of 3 and a variable of m and a mathematical operation. 3m means 3 times m. We're also going to evaluate these when m equals 4. So if I said evaluate 3m when m equals 4, you would need to know that that does not mean 34. I will have people tell me that. Well, 3m just means 3 in a number, so it's 3, 4. 34. No, no, no. Because when I have a number next to a letter like that, when I have that coefficient next to the letter, then that has an implied multiplication there. So 3m means 3 times m. So if I put a 4 in there, it becomes 3 times 4. When they say m equals 4, basically we're sticking a 4 in place of the m. So 3 times 4, 12. What about 3m squared? Well, we know 3m means 3 times m. But what does m squared mean? Well, we had that in the last section. M squared is an exponent, right? With a base of m and an exponent of 2. So it literally means we're multiplying by the base, m, not times 2, times itself twice. That's what 3m squared means. So I could evaluate that when m equals 4, and this would just become 3 times, and everywhere there's an m, we would replace it with a 4. Then we can evaluate that. 3 times 4 is 12. 12 times 4, I believe, is 48. Please beware, 3m squared does not mean these do not mean the same thing. In this situation, and this actually has to do with the order of operation, only the m is being squared. See, this literally means 3 times m squared, 3 times m times m. Exponents occur before multiplication. PEMDAS, right? Write that down again. P-E-M-D-A-S. The exponent 2 comes before the multiplication of 3 times. That's why it does not mean 3m times 3m. What is the only thing that comes before exponents in order of operations? Well, there's that letter P, right? So if I wanted it to mean 3m times 3m, it's not a big deal. I would just need to put that 3m in parentheses. And then that would basically make that order, that P would occur first. So now what's being squared is not just the m, not just the 3, but the group. The group is actually the base in this situation. So the group is the base multiplying by itself twice. And then if I evaluate it when m is 4, this would become 3m, keep in mind, means the same thing as 3 times. 3 times. So this would mean the same thing as, now evaluating it 3 times 4. 3 times 4. You should probably know our order of operations here. So we are going to handle the inside of the parentheses first and get 12 times 12, or 144. So this should be, I mean, honestly, I think the arithmetic in the last section was probably more complicated. This is more kind of focusing on definitions, writing things out as what they mean, and evaluating by substituting numbers in and doing order of operations. So shouldn't be a difficult section to finish up. What about this mess? So this mess, basically, we have 4x minus 2y over x plus 1. Okie doke. So how do we handle that? Well, 4x means 4 times x. 2y means, or minus 2y means minus 2 times y. And x plus 1 just means x plus 1. So we're going to substitute. Everywhere there's an x, this says x equals 6 in this question. So everywhere there's an x, we put a 6. This says that y is 9. So everywhere there's a y, we put a 9. So let's substitute that in. We get 4 times, what's x? Minus 2 times, what's y? All over x plus 1. Now there's a lot going on in this question, right? How do I know what to do first? Well, when I have this right here, I know that this line means division. We do that all the time. If I had something like 8 over 4, you would know that that means 8 divided by 4, and we'd have 2. And we'd be like, okay, yeah. But what we also need to remember is that it groups. Basically, we have 2 groups. We have a group on the top of the fraction and a group on the bottom of the fraction. And so we have to handle those separately. They're almost like 2 separate questions. We have to handle those groups separately and then do that division at the end. So PEMDAS again, we're going to start on the top. I see multiplication. 4 times 6 is 24 minus 2 times 9. I'm not going to skip any steps here. I'm just going to deal with the top for now, and then I'll bring the bottom down. Okay? It is tempting to do 24 minus 2, but that 2 times 9 multiplication trumps the subtraction. It occurs first, right? It is first in the order of operations, so that this becomes 24 minus 2 times 9. And then 24 minus 18 is 6. That's just the top, right? That's not the answer. That's just the top of the fraction. You have to remember now at the bottom, 6 plus 1 becomes 7. Now, if I could divide this, I would, but 6 over 7 doesn't simplify, so that's how we would leave that. This is going to take a little bit of time, so I'm going to kind of talk through these, but you're going to need to make sure, write them down, pause it as you need to. But here are some symbols we're going to see. We're going to see an addition symbol. a plus. Other words we use for that: sum, greater than. We talked about that in the last section, but the key here is that we are not saying is greater than. This is not an inequality. That is makes it an inequality. This doesn't have the is. Okay? Or we could say increased by. If I said 5 increased by 2, we would add, right? Here we have a subtraction symbol. We also use the word minus. Or if I said, what's the difference of two things? If you have 10 and I have 12, what's the difference? Well, you would subtract them to find the difference between those numbers. You could also say less than, decreased by. All of those have an implied operation of subtraction. Multiplication, now be careful. Sometimes we use an X for multiplication. It's not like a letter X, it's almost like a little X. I think better is to use the dot or the asterisk, but basically we have multiplication. People will do this. They'll do 2 like that, and that has a multiplication. That's fine. Or 2 times 3. Those mean the same thing, right? So it's not like an X, like a variable, and that's kind of one of those weird, confusing things in mathematics, but people do that. This is multiplication, or timesing something, or the product. All of those are terms you need to know. Onward. We already talked about this symbol, division, divide by, quotient, but a lot of people don't think of it, but over. Over means division. We do it implied. This says 8 over 4. This means 8, and this line right there, that over, means division. This is the same thing as 8 divided by 4. 8 over 4 is the same thing as 8 divided by 4. And we saw that 8 over 4 is 2. Be careful, because 4 over 8 is not 2, is it? 8 divided by 4, 4 goes into 8 2 times. 4 divided by 8, or 4 over 8, is not 2. It actually ends up being the fraction 1/2. We could simplify it. But the idea is, a lot of people do 4 over 8, and they'll go, oh, just divide 8 by 4. No, no. This means 4 divided by 8, not 8 divided by 4. So be careful with that. You also need to be able to check solutions. So they're going to give us equations, and they're going to ask us, and this is how they're going to ask it. I don't really like it, but they'll say p minus 1 equals 3, semicolon 2. And they'll say, check the solution. What they're basically saying is p minus 1 equals 3. Does p equal 2? That's the question. Okay? So this number at the end is their way of saying, is that the solution? Is p equal to 2? Question, right? Well, check it. If p equal 2, we should be able to take that 2 and put it in place of the p. So this would become 2 minus 1 equals 3. 2 minus 1 is 1. Does 1 equal 3? I'm not liking that, right? So if this is not true, if this is false, then that means p is not equal to 2. Or we could say that 2 is not a solution. It doesn't solve this, right? Keep in mind, they're not asking you to solve this at this point. We will be doing that. They're just asking you, is this the solution? If you can see it, cool. You're like, well, I knew p was 4, so p is not 2, and I just keep going. Okay, that's fine. But what happens as it gets a little more complicated, like 7p minus 11 equals 5, semicolon, 16 over 7. What the heck? What are they asking again, right? Well, they're asking, is p equal to? That's what they're really asking with this last statement, right? This is they're saying, does it equal 16 over 7? I don't know. Off the top of my head, right? You're not just doing that in your head. We need to be able to check it. So just like we did before, I can take that number and I can plug it in for p, and we get 7 times 16 over 7 minus 11 equals 5. So we put that in its place, and then we can analyze it. You have two options of doing this. There's the easy way, which is to see that the 7 multiplying and 7 dividing cancel, and so I'm just left with 16. If you're like, I didn't see that, you could take that 7 and multiply it by 16 over 7. And you would get 7 times 16. What would that be? 70 plus 42. And then you'd have to divide 112 by 7. And you would get 142. What is that? 6? And so you would get 16. I think it's really nice when you can see the 7s cancel. That was a lot of like sad work, but it gets you the same answer. So if you don't see that the 7s cancel, it doesn't mean your mathematics has to shut down. You can still multiply the top straight across and then divide it. But basically multiplying by 7 and dividing by 7, they cancel each other out, so I'm left with just the 16. Okay? Then we got 16 minus 11 equals 5. Keep evaluating. 16 minus 11. We get 5 equals 5. That is true. Which means what? 6p equals 16 over 7. Or we could say that 16 over 7 is a solution. Last but not least, what we need to do is just look at these sets here, and they're going to ask you whether questions are expressions or equations, right? And keep in mind, again, the key feature here is that expression is just basically a set of both variables and constants kind of mixed together with mathematics. But equations has a key part, that equa, I'm looking for any equal sign. So if I said 2x plus 5y minus 7, did I say equal at any point? No. That makes that group an expression. Now if I said 2x plus 5y equals 7, that equals gives me that equation. It makes it an equation. What about, sorry, I'm making a mess here. What about x over x minus 3 equals 4x? The minute I said equals, that equals makes it a what? Equation. 2x minus 5, or 2x plus 5 equals 7. The minute we said equals, that makes it an equation. And last but not least, not to be undone, 3x minus 1 over 5, or divided by 5. Never at any point did I say equals, so that makes that an expression. If you don't like my arrows, I get it. I could do expression. Equals makes it an equation. Equals makes it an equation. Equals makes it an equation. And no equals makes it an expression. Why does this matter? Well, anytime I have an equation, I'm going to be able to solve for something. I'm going to be able to solve that for x, for y, for some variable. I'm going to be able to solve. When I have an expression, if I say 2x, which is an expression, I can't solve that. I don't know what x is. There's no equal sign to try to solve it. All I can do is I can evaluate. If I said, well, what if x were 5? Well, then 2 times 5 is 10. What if x were 15? 2 times 15 is 30. I could evaluate an expression with different values of x. But whenever I have an equation, I can solve. So this is really an important feature because we're going to be dealing with expressions, and I have students that will start solving them. They'll go, well, 2x. They go, well, x is 2. No, there's no equal sign. There's no way to know that. Whenever you have an expression, you can only evaluate different values, and whenever we have an equation, we can actually solve. Very different. So that's it. 1.2 I think is relatively light. A lot of definitions, but the mathematics should be a little easier than the last section. So You shouldn't have any problem knocking these out. Be coming in ready for the quiz in 2 days. And I will keep in mind, if you are all ambitious, get to work on the next sections of notes. I have them on there. Get through them, take them down, and then come prepared in class. You can either take the notes in class in 2 days, or you can come and work on homework, and I'll be here to help you. I really think this will be helpful, so let's give it a try. I'll see you guys in 2 days. Thank you. For section 1.3, we're going to start with just a lot of vocabulary. So I'm going to go through this kind of at my pace, but keep in mind that you can feel free to pause this, copy this down as you need to, and also keep in mind that I will be checking notes, so this is not something that's optional. But let's go ahead and start with the number line. So when I'm dealing with the number line, we know that if I look right in the middle of the number line, kind of the center of that would be 0. Everything to the right of 0 we represent as a positive number. So those would be all our positives, 1, 2, 3, 4, 5, 6, so on and so forth. Everything to the left of 0 we classify as a negative. So that would be our negative 1, 2, 3, 4, 5, 6. The further we go to the right, the higher the positive. The further we go to the left, the lower the negative. We also classify these in different categories. So, for instance, and this is stuff you will need to know for the test, so I would encourage you to write these definitions down, and as you go through the homework, if there's any that you're not certain about, put them on a note card and have those ready. But our first type here is going to be counting numbers. And kind of my history for this is this is all of our positive numbers, all our positive whole numbers except for 0. And the main reason we do that is that 0 is actually a pretty complicated idea. There is no 0 in Roman numerals, for instance. In fact, the first culture to come up with the idea of a 0 that we have historically was in the Americas. We had, I believe, the Aztecs had a representation for nothing. So if I'm counting something, you're like, well, why do I start at nothing? And in mathematics, we have a lot of reasons to have a 0, but that was not intuitive. So when we do our counting numbers, that's just like, well, you don't start counting at 0. You start counting at 1, 2, 3, 4, 5, and this represents the set of all whole numbers starting at 1. When I say the term whole numbers, though, that whole numbers includes a 0. So that's the only difference. As we're going down, we're basically adding things. So for instance, everything that is a whole number is also a counting number. The 1, 2, 3, 4 is up here as well. 1, 2, 3, 4. The only thing we added when we say whole numbers is that 0. When we talk about integers, that takes us past to the other side of 0. So instead of just being 0, 1, 2, 3, 4, 5, we now have negatives on that. So here we had, let's see if I can kind of color code this, all of our counting numbers with these yellow positive whole numbers. Whole numbers included all those as well, but added that 0 from before. That is not the color I wanted, so let me try that again. The 0 there. And then what happens when I do integers? Well, we still get all the positives on the right, but we also now add all the negatives on the left. And so basically everything that is a counting number is still a whole number, is still an integer. 3 is in all 3 categories, but not everything that is an integer necessarily is a counting number. Some integers, like all these yellow ones, are going to be in the top 2 classifications as well. So these are kind of our definitions: counting numbers, whole numbers starting at 1, whole numbers starting at 0, integers, we now add both positive and negative. This is called set notation, the symbol that we're using. It's a little like braces, and then we put all the elements there in the middle. So this is not something I'm necessarily testing you on, but it is something we do a lot more in Math 51, and I wanted to make sure that you had seen that term and know what it means. Another term that they're going to be using, like I said, a lot of definitions, is if I say the opposite. What is the opposite of a number? Well, physically, if I'm talking about the number line, it's on the opposite side of 0. So if I do the opposite of 5, I go up to the number line, I find 5, and if I were to jump all the way to the opposite side of 0, I would get to negative 5. So the opposite of a positive is negative. What about the opposite of a negative? See, what if I went up here and I started way back here at like negative 16, and I jumped to the other side of 0, right? Where would we end up? Well, if we jumped to the other side of 0, that would no longer be negative. It's the same distance. We jumped equally to the other side, and so it would be positive 16. That would be the opposite. This gives us a good reason for basically thinking about opposite of. If I say opposite of, basically we put a negative in front. So the opposite of negative 16 is negative negative 16, or just positive 16. That's a little more than you need for this section, but that's going to be something that we're going to be building on in the future, that when I do the opposite of a positive, I always get a negative. If I do the opposite of a negative, I always get a positive. We can do different sets, and they're going to have you doing some of this in the vocabulary. If I said the set of positive even numbers, well, I know I'm dealing with only positives, but evens mean I'd be doing things like 2, 4, 6, 8, and this dot 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 means that those even numbers go on forever. Okay, so hopefully you take a second, write that down. Here's another way of thinking about when we're dealing with integers specifically. If I say the lowest temperature was 190 degrees Fahrenheit below 0, right? That is a situation where we need to have integers. We can't just have positive numbers in real life, because if I have 129 degrees below 0, then that means the temperature was not a whole number, it was an integer at negative 129 degrees. The shore at the Dead Sea is 1,348 feet below sea level. I forgot to put feet in there, but I'll throw it in. Feet below sea level. What does that below sea level do? Well, if I was talking about the elevation, that would mean we would not have a positive elevation, we would have a negative elevation, or negative 1,348 feet. That would be the elevation for the shore at the Dead Sea. So you can have elevations that are above the sea, positive elevation. You can have elevations that are below the sea, negative elevation. Our next type are rational numbers. See, rational numbers are basically any number, x, anything, such that or given that that number can be written as a fraction. Any number that can be written as a fraction is a rational number. That includes all the numbers we have had so far. For instance, 2 is a rational number. You're like, wait a sec. I thought that was a whole number. It is. And it's a counting number. But why is it a rational number? Can 2 be written as a fraction? Yeah, 2 over 1. So basically that means that all of our whole numbers, all of our counting numbers, and all of our integers are all still rational numbers, because all of those can be written as a fraction. Any whole number can be written as a fraction by putting it over 1. So what do rational numbers add? Well, they add fractions. Rational actually has the root word at the beginning, ratio. Ratio means fractions. So anytime I see a fraction, negative 5, it's not a fraction, but we could make it a fraction. Therefore, it is rational. Something like 2/5, obviously, is a fraction. So that is rational. But we also say, so that's if it can be written as a fraction, any of our whole numbers and any fractions. But we also say, or if it's a terminating or repeating decimal and fraction, okay? So basically any terminating or repeating decimal and a fraction. What do I mean by terminating? Well, I could take 2/5 and I could take that fraction and turn it into a decimal. This we talked about before. This literally means 2 divided by 5. If I put a decimal on a 0, 5 goes into 24 times. So that means if 2/5 is rational, so is 0.4. Why? Because it is a terminating decimal. What does terminate mean? It ends, right? You want to terminate something? It ends. So this is a terminating decimal. Any decimal that ends, that is not non-ending, right? It stops, can be written as a fraction. 1 3/4. Obviously, 1 3/4, we got a fraction, but you're like, yeah, but it's got that 1 there too. Well, a couple ways of doing this. I could turn this into a mixed number by doing the whole multiply and add. I multiply the whole number. Remember, I think of fractions as part over whole. This says I have 3 parts, and 4 parts make up a whole. I have a whole of something. I have 1. That is one whole number. If I want to turn that into a fraction, I take that 1 times 4 because I have one whole part. I multiply it by 4 and I turn it into 4 parts. Add the 3 more to it and I get 7 parts where 4 make a whole. This is still a fraction. This is still rational. I could also take that 7 and divide it by 4. Notice what? 4 goes into 7 one whole time. That's that whole number. With a remainder of 3, bring down to 0. 4 into 30 would be 7. Leaves us with 2. Bring down a 0. 4 into 20 would be 5. And this is now terminated. 1 3/4 or 7/4 is the same thing as 1.75. A terminating decimal. That makes it what? That makes it rational. If it can be written as a fraction, it is rational. It can be a ratio. Any decimal that ends, terminates, can be written as a fraction. Any fraction can be turned back into a decimal. That also includes 0. 0, since it was included before, is still rational. How do I know? I could stick it over 1 and it is still 0. I can make it a fraction, 0 over 1, and it's still 0. Therefore, it is rational. What about this 0.3? Well, I already told you 0.3, any repeating decimals, this is going to be rational. You're like, really? But I thought you said ratio means it has to be a fraction. Well, that's what's kind of cool about any repeating decimal can be written as a fraction. This 3, basically, and this is kind of a trick, you take whatever's being repeated, the 3, and you divide it by a 9. 3/9 is the same thing as, divide the top and bottom by 3, 1/3. If I take 1 and I divide it by 3, I get 3 is 9, leaves me with 1. Bring down a 0. 3 makes 9, leaves me with 1. Bring down a 0. The idea is what? As this goes, that 3 is going to keep repeating. Okay? So any repeating decimal can be written technically as a fraction. We could turn that into a fraction. Therefore, it is a ratio or a rational. What about 4.7? That's not a fraction, not a repeating decimal, but you got to remember from before. If it's a decimal that terminates, then it is still rational. Okay? So let's go back up over the definition real quick. Rational, any number that can be written as a fraction. What does that really mean? Any number where the decimal terminates, that was right here, or repeats. And any fractions. So anything that can be written as a fraction, is going to be rational. That's the easy one. But basically what? Any decimal that terminates, or any decimal that repeats. All of those are rational numbers, ratios. Let's take this fraction, right? Where is 4/3? And I love the way this book kind of really goes into some number sense, because my saddest thing is when I see people take 4/3 and go, I don't know, is that it's between 3 and 4, right? It's got a 3 and a 4 in the number. Yeah, but no. What does this mean? Remember, we talked about before in the previous section, this says 4 over 3, or 4 divided by 3. So I can take that 4 and divide it by 3. What we divide by goes on the outside. And 3 goes into 4 one time. If I want to continue and kind of see where this continues to go. 3 goes into 10. 3 times. 3 times 3 is. Bring down another 0. 3 goes into 10. Oops, sorry, let me fix that. Got all excited there. 3 times. 9 leaves us with a 1. What's going to happen as we keep going? This 3 is going to be repeating. So what would our answer be? 1.3 with a line over it. If we rounded it, then we would stop it at 1.3 or however far they wanted us to. But this is how I would show that that is a non-ending, non-terminating decimal. Okay? So you need to know how to turn those fractions into decimals. Notice 4/3 is not between 3 and 4. What is it in between, really? Well, 1.3 is between 1 and 2. It is larger than 1, but it is less than 2. What about 23/8? I don't know. Take 23 divided by 8. How many times does 8 go into 23? 8, 16, 24 would be too big. So 8 times 2, take it away, leaves us with 7. I could keep going. 8 into 7. I feel like I need more space here. How about 8 into 70? 8 times 9 is 72. That's too big. 8 times 8 would be 64. Leaves us with 6. Another 0. 8 into 60. 8 doesn't go into 60 evenly, but I think 8 times 5 is 40. 8 times 6, 8 times 7 would be 56. Can I stop yet? Has this number terminated or repeated? Then I need to keep going. Okay? I am going to make some extra space here. Sorry, I know this is kind of messy. So I'll just shrink that. I'm sure you can all do that as well. And I'll move this. Alright, we're almost done. 60 minus 56 is 4. Put another 0. 8 goes into 40. Finally, evenly. 5 times 8 is 40. So notice 23/8 is not between 8 and 23. 8 goes into 23 2 times with some mess. We finally had nothing left, so it is 2.875. You need to know how to turn fractions into decimals. All of those are our rational numbers. Any decimals that terminate, any fractions, any decimals that repeat. Our next category is called radicals. So we were on, let me make sure we're clear, that was on 4. So we are on 5. Radicals are irrational numbers. What is the square root of 8? Like, I don't know. Remember, square root means what number times itself makes 8. And here's where I have some people go, well, that's not, there's no number that does that. And technically, that's not true. You're not completely off the deep end, because for a long time, mathematicians didn't think there was a real number. But we will prove in more advanced mathematics that there are real numbers that times themselves make 8. But what I do is I go, well, I know it's between two numbers. How do I know? Well, I know the square root of 4. What number times itself makes 4 is 2. And I know that the square root of 9 is 3. So doesn't it make sense that the square root of 8 would be between the square root of 4 and square root of 9? Isn't 8 between 4 and 9? Then that means that our answer must be between 2 and 3. Between 2 and 3. What was the other example that we got for radicals? Was we had something like the square root of, I think it was 76. Well, what is that between? Well, we're already at the square root of 9, right? That's not high enough. What's the next number that we get? What is 4 the square root of, right? The square root of, still not high enough. But 5 is the square root of. 6 is the square root of. Still not quite to the square root of 76, right? 7 is the square root of. 8 is the square root of. We're getting pretty close, right? 64 is pretty close to 76. And 9 is the square root of. I know that 76 falls between these two numbers. which means that the square root of 76 must be between 8 and 9. These are called irrational numbers. In fact, if we think about what irrational is, irrational literally means numbers that don't make sense. It doesn't mean they're not real. Just because something doesn't make sense doesn't mean it's fake. But numbers that don't make sense are irrational. The square root of 8 is irrational. It doesn't make sense that there's some number times itself that makes 8. But it is real, and we'll prove that. Okay? But things like the square root of 2. That is a non-repeating decimal. There is an answer to that, but that is a number that goes on and on and on forever. Pi is irrational. If you take any circle, if you take the circumference and divide it by the diameter, you always get pi. Does that mean you always get exactly 3.14? No. It is a number that keeps going on forever. It is a non-repeating decimal. E is another number we see. When we do more in the sciences, you'll see that a lot in Math 51. It's 2.71. Not exactly. In fact, I think it's like 2.715. It keeps going on. It's like pi. It goes on forever. It has to do with science. It has to do with growth. It has to do with things that we see in nature. It is a real number that doesn't make sense. And so when we discover those, we called them irrational. They are still decimals, but they are non-repeating decimals. The square root of 2, if I were to write that out, there is a decimal, but it is a non-repeating decimal. Last couple things. So that was kind of the hefty part, a lot of definitions. This, I actually like this. You need to be able to plot numbers on the number line. Some of them are easy, and we're going to do like an approximation. But like -3, right? -3, I know that it's negative, so we are on the left side. And I know that we're going 3 to the left, so that one's actually easy. We just plot it. There's our -3, right? Done. Where's 17/8? I'll give you a hint. Don't put it between 8 and 17. What do you need to be able to do? Well, take 17/8 and divide it. This basically says 17 divided by 8. I don't need the exact decimal. I just need to know how many times does 8 go into 17? Well, 2. I could do a decimal and a 0. 8 into 10, 1. I could keep going. I think I'm going to get like another 2 and a 5. But what did I get? I got 2 point something, 2 point mess. What does that mean? Well, 8 goes into 17 2 times. We had something left over, so this number is between 2 and 3. That would be our 17/8. Between 2 and 3, closer to the 2. Where's -2.75? Well, there it's almost easier when they're decimals, right? That means -2.75 is between -2 and -3. 75 means it's closer to the 3, so we put that dot. Where's 1 1/2? Well, I know this is 1. If I go 1/2 more, that's 1 1/2. If you're not sure, you could turn that, and I wouldn't do this, but you could turn this into a mixed number, an improper fraction, and make that 3/2, and do 3 divided by 2, which would give us 1.5. But there's some options there, so that's 1 1/2. -3/4. Do not put that between -3 and -4. Like, yeah, put it between 3 and 4. No. What is 3 divided by 4? What's interesting this time is the 4 doesn't go into the 3. Not even once. It doesn't go into any whole times, right? 4 goes into 37 times, but that doesn't make that 7. That makes it 0.7 when I bring that decimal up. Leaving us with a 2, bring down the 0. 4 into 20, 5. 5 times 4. So what are we looking at here? Well, don't put it at positive 0.75, because don't forget it was negative, but basically this is the same thing as negative 0.75, or -3/4, right? Where does that really go? Between 0 and -1. That would be our -3/4. And last but not least, where the heck does the square root of 6 go? What number times itself makes 6? I don't know, but I know what it's between. I know that the square root of 6, I can't do the square root of 5, but I can do the square root of 4. The square root of 4 is 2. I don't know the square root of 6. I go up now. I don't know the square root of 7. I don't know the square root of 8, but I do know the square root of 9 is 3. So doesn't it make sense that if the square root of 6 is between 4 and 9, right, that our answer must be somewhere between 2 and 3. Somewhere between 2 and 3, we're going to put that square root of 6. So you will need to be able to do that. There are going to be some questions to give you lists of numbers, but they're going to give you pictures. So if you can do this on the paper and kind of match it on the picture, something you can expect to be able to do on the test. Let's keep going. It says true or false. Is negative 2 less than 4? What does less than mean? Well, we know it means below then, right? But what does it mean on the number line? Well, it means a number that is further to the left. Any numbers to the left are less than. Any numbers to the right are greater than. Is negative 2 less than 4? That is true. How do you know? Here's 0. To the left is negative 2. To the right is positive 4. So since negative 2 is further to the left, that makes it less than 4. Is 6 greater than negative 3? If less than means further to the left, greater than means further to the right. So here's my number line again. 6 is over here to the right. Negative 3 is over here to the left. Is 6 greater than, further to the right, than negative 3? That is true. Is negative 9 less than negative 12? Here's where I start catching people. People look at this and go, yeah, absolutely, this is true. Is negative 9 further to the left of negative 12? Well, if I had my number line, and I went back 1, 2, 3, 4, 5, 6, 7, 8, 9, negative 12 would be further to the left. Is negative 9 below negative 12? Is negative 9 to the left of negative 12? That would be false. You're like, that makes no sense. 9 is less than 12. I understand what you're thinking, but a greater negative is less. Think of it this way, right? If you have like a credit card, right? Who has less money? Somebody that owes $9 or somebody that owes $12? The person with the greater negative, the greater deficit, has less money. Further to the left means less than. Is negative 4 greater than or equal to negative 1? Well, I know it's not equal to, but what does greater than mean? Is it further to the right? Well, now we got 0, negative 1, 2, 3, negative 4. Is negative 4 greater than to the right of negative 1? See, if you can think of a number line, this utterly becomes nonsense. You can see that and go, that is false. A greater negative is not greater. It is actually less than a smaller negative. Is negative 6 less than or equal to 0? If you're not sure, here's 0. Where is negative 6? This says negative 6 is less than or equal to. That means negative 6 is to the left of 0. That is true. All right, where are we at? Absolute value. I'm going to go ahead and erase this. When we talk about absolute value, what a lot of people do is they'll give me kind of the book definition, and that doesn't make me sad. They go, well, an absolute value means that the number is always positive. I like to ask the question, why? Why is it always positive? And you're like, well, because I told my teacher that, and they gave me a gold star, and I felt good about myself, so I knew it was always positive, right? But that doesn't make it true. So why is absolute value always positive? Well, it has to do with what absolute value means. When we talk about absolute value is a number's, here's the key word. Some of you already know this. You're screaming at the screen. It is a number's distance from 0. Why did I underline the word distance? Why is that significant? Distance is always positive. If I drive my car to LA, and I drive, 150 miles, that is a positive distance. If I feel like a smartass and I throw my car in reverse and I drive 150 miles, it does not mean I went negative 150 miles. That's utter nonsense, right? Distance is always positive. If I sign up for a PE class, or if I'm involved in a sport and my coach says, hey, go run a mile, and I feel like a jerk, and so I'm mad at him, and I jog the whole thing backwards. You get to the end of that mile, and the coach looks at you and goes, that was a negative mile, now you owe me 2. It's utter nonsense, right? Distance is always positive. The person that's sitting in front of you is a distance from you. The person sitting behind you is a positive distance from you. Distance is always positive. So when I say what is the absolute value of negative 5, what I'm really saying is what number is 5 away from 0, right? How far is negative 5 from 0? If I go from 0 to negative 5, it has a distance of 5. Always positive. If I said what's the absolute value of 5, how far is 5 from 0? It is still 5 away. If I take the two numbers, 5 and negative 5, they are the same distance from 0. So both of their absolute values are positive 5. Now don't fall for it though, because you're like, oh sweet, so then the next one's going to be 5 and the next one is going to be... No. Look, you have to still do order of operations. The absolute value is kind of like a parentheses. So I'm doing this, I have to take care of this first. So what is the absolute value of 5? Out of here comes this positive 5, but this negative is waiting for it, right? And it gives me the opposite of. It gives me the opposite answer. So the absolute value of 5 is positive 5, but then I end up with a negative 5, or just negative 5. On this one, he's like, oh, I know this. 2 negatives always become positive. No. I mean, most of the time, yeah. But what do I do first again, right? The absolute value, the grouping. What is the absolute value of negative 5? Out comes a positive 5. That negative is waiting on the outside that makes my answer a negative 5. So it's not that the answer is going to always be negative, but the result, whatever comes out of an absolute value, will always be positive. This next one is more like what you're going to see in the homework. If I have negative absolute value of 8 minus 5, once again, order of operations, starting on the inside, starting in the, not the parentheses, but they're like parentheses, the grouping. You do 8 minus 5 is, and then you bring the rest down. Absolute value, bring the negative. What's our answer? You're like, it's always positive. Be careful, right? What is the absolute value of 3? Out comes a positive 3, and so I end up with negative of 3 or negative 3. The only other term that they're going to use that you need to be comfortable with is going to be additive inverse. Additive inverse is another way of basically just saying the opposite. But what does it really mean? Additive inverse. What can I add to cancel? What can I add to 15 to cancel it out? Well, 15, if I had a opposite, negative 15, they would cancel each other out. What is the opposite of negative 9? A positive 9. If I had a negative 9 and a positive 9, they would cancel each other out. Additive inverse. But if they use that word, it just means opposite. I'm not as big on that. We're going to use it a little bit later, but I just didn't want you to freak out when you saw it in the homework. So for section 1.4, we're going to be adding real numbers. People tend to do really good at this section, so you want to make sure that you take your time and understand this section, because the next one, subtracting real numbers, we actually will bring back to adding. So if you're really good at this section, most people, they get comfortable at this, then we'll learn how to take section 1.5 back into section 1.4, and you'll have no problem doing these, okay? So let's start with some easy stuff. What if I add 2 positive numbers? A positive plus a positive number gives me a result that is positive. And that makes sense. That's intuitive. You're like, yeah, 1 plus 37. If I add 1, if I have 1 and I add 37 more to it, I have a total of 38. When they are the same sign, they will combine. Well, that's also important, because what happens if I add two negative numbers? A negative plus a negative gives me a result that is negative. When they are the same sign, they combine. If I have negative 3 plus negative 7, the two negatives combine. They don't cancel each other out. Think of it this way. If I get 1 and I get 37, I get 38. But if I owe 3 and I owe 7, I don't all of a sudden have $4. If I owe and I owe and I owe, if I take then I have negative and negative and negative, then those combine and they stay negative, and I end up with 10 negatives. This is my favorite way to explain it. There's other ways kind of as we go, and I'll show you. But the idea of taking the same sign and combining, to me that makes sense. You can use the number line. If you're not liking the way I'm covering this and you want to try using the online, I believe they're going to try to explain it with the number line. Just to me, that gets a little more complicated. Okay, so we know a positive plus a positive, they combine to make a positive. A negative plus a negative, they combine to make a negative. Same sign, we just combine the numbers, we keep the sign. What if they're not the same sign? What if I have a positive plus a negative? Or a negative plus a positive? Well, it matters. And why does it matter? Well, because if they're the same sign, they don't combine. I'm sorry, if they're the same sign, they do combine. If they are opposite signs, then they cancel. And I'll kind of show you a visual for this to help you understand it. But if I had 17 negatives and I put in 11 positives, and I'm going to draw this out. If I had friggin' 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, what was it? 17 negatives. Every time I put a positive in there, 3, 4, 5, 6, 7, 8, 9, 10, 11, every time I have a negative 1 and a positive 1, they make a 0. Every time I have a negative 1 and a positive 1, they cancel each other out. And every positive cancels with every negative that we have. And so what am I left with? Well, we end up with more negatives, right? So we end up with negative 6. What we do is we cancel and we keep the larger sign. Why? Because that's what we're left with. If I canceled out 11 positives from 17 negatives, I still have 6 more negatives. If I owe you 17 and I put in 11, I don't all of a sudden have $6. It doesn't work that way. I still owe you. I still have a greater deficit. I still have more negatives. On the flip side, if I took those 17 negatives and I did, instead of 11, if I did 19 positives, 14, 15, 16, 17, I would have what? After all of these zeroed out, I would be left with 2 more positives. So all we really need to do is actually kind of subtract. When we cancel, we are subtracting. I really would just take this, and we take the larger number minus the smaller number, and I'm left with 6. That's what canceling is. What you have to remember is to keep the larger sign. Why? Because even though I'm subtracting these, I'm canceling them. I'm left with not 6 positives, but 6 negatives. So when I have negative 17 plus 19, I take the larger number. I cancel out the smaller number, because they're going to cancel out and leave me with 2. But 2 what? We had 2 more positives. So that's what we're left with. So same sign, we combine. When I have opposite signs, the answer matters. It changes. They'll always cancel, but it won't always be positive, it won't always be negative. It always depends on which one has a larger sign. So if I have 20 plus negative 13, I don't feel like jumping on a number line. I don't feel like drawing out 20 positives and 13 negatives. You need to remember that if they are the same sign, they combine. These are opposite signs, so they will cancel. How will they cancel? Well, I have 20 as the larger number. cancel out the smaller number. 20 minus 13 gives us 7. That does not mean our answer is 7. What you have to remember is 7 what? What did we have more of? When I canceled out the positive and negatives, I was left with 7 more positives. What if I have 20 plus negative 35? Well, what's the larger of those two numbers? 35. I cancel out 20 of those, leaving me with 15. That doesn't mean the answer is 15. You have to check it. We were left with 15. When I canceled 20 positives with 35 negatives, I was left with 15 what, though? 15 more negatives. I could draw that out, but as I keep going, I don't want to, on the next example, I don't want to have to draw out 89 negatives. I want to do it when it's easier, so I get to this one, I go, okay, these are opposite signs. They cancel. Whenever I have a positive one and a negative one, they zero each other out when I'm adding them, right? So I'm going to cancel, and I'm going to do the larger number minus the smaller number, leaving us with 77. 77 what, though? We have more negatives. 12 plus negative 81. We cancel. 81 minus the 12. 70. I think that's 69. 69 what, though? We had more negatives. So check that out. When they are the same sign, they're going to combine. When they're opposite signs, they're going to cancel. That's really the only big concept for this. Now what we're going to do is we're going to take this and kick it up a notch. We're going to do this with fractions and decimals. Oh boy! Look at this next example. 1/2, negative 1/2 plus 1/8. Are they the same sign? No. They're opposite signs, which means we're going to cancel. But I can't do anything with fractions unless they have a common denominator. I need the pieces to be the same size. I got a 2 and an 8. Yes, I can make them both a 16, but the LCD of 2 and 8 is just 8. I don't have to change the 8. I could just change the 2 into an 8. It's not wrong to make it a 16, it just means you're going to have to simplify more at the end. It makes your life harder. So how do I change that 4, 2, and 8? We give them a common denominator by multiplying. I cannot just multiply to the bottom. I must also do it to the top. Because it makes sense. If I just did it at the bottom, then 1/2 would turn into 1/8, and that doesn't make any sense. 1/2 and 1/8 are not the same thing. If I do it to the top and the bottom, then 1/2 is the same thing as 4/8. And 4 out of 8 is half. If I've got 4 out of 8, that's half of something, right? So this is still 1/2, just in a different form. So this becomes negative 4/8 plus 1/8. We already said the signs are opposite, so we are going to what? Combine or cancel? Same sign, combine, opposite side, cancel. So I'm going to cancel, take the larger number, minus the smaller, and that gives us 3. When we cancel out the parts, negative 4 plus 1, I'm left with 3. But 3 what? We had more negatives. What happens to the denominator when I add fractions? Well, I combine the numerators, but I leave the size of the pieces, I leave the denominator the same. So all those skills from the previous course don't go away. You need to handle decimals and fractions. Let's kick it up a notch. 5/6 plus negative 1 1/3. Once again. Now first of all, I'm dealing kind of with a fraction, but the issue here is that the second one's not really looking like a fraction. You need to know how to turn a mixed number into a fraction. So we need to be able to multiply and add and make this 5/6 plus 1 times 3 is 3 plus 1 is 4. Keep it as a negative. So now I got 5/6 plus negative 4/3. These are not ready to add. I need a common denominator for 6 and 3. Our least common denominator would be 6. So, and these are arrows basically. We're kind of continuing on. So now, if I want to make that a 6, I leave the first one alone. I multiply the second one, top and bottom, by a 2. So that's going to make that plus. What does this do for me now? Now that they have a common denominator, I can add the numerators. I can add the top. What is 5 plus negative 8? Well, when they're opposite signs, they cancel. So I do negative 8, the larger number, 8 minus 5, I cancel them, and I'm left with 3. But 3 what? We have 3 more negatives. So negative 3 over 6. Some of you want to circle and keep going. I'm going to tell you right now that if you type that in, hit enter, they'll just be real nice and say, don't forget to take your answer and reduce it. 3 and 6 are both divisible by 3, so that we end up with negative 1/2. There are a lot of steps to this, and I'm going to have you do this type of thing on the test without a calculator, but do keep in mind, something like not reducing at the end, I'm not going to make that a right or wrong. That'd be like a quarter point. There are a lot of steps to this and a lot of points. So the little mistakes, yeah, don't try to make them, but the idea is that it doesn't have to be like a make or break it issue. Just go ahead and be comfortable with your integers, be comfortable with your decimals. This is going to be our last chapter where I'm not letting you use that calculator. But if we have a decimal, the rules don't change. Opposite sign, we cancel. So I take the larger of these two numbers. Which one's larger? Well, how about the 8.1? I cancel out 4.6. 1 minus 6 is not just 5. I cannot have one finger and take away 6 of them. That's really weird. So we regroup from the 8 and make that 11 minus 6. 11 minus 6 is 5. But now this 8 got borrowed from, so it's 7 minus 4 is... So my answer is going to be 3.5. Positive or negative? Which one was greater? We had more positive, makes that answer positive. What if I had just changed the signs on that question and had the 4.6 positive and the 8.1 negative? Well, they're still opposite signs, aren't they? So what does that mean? We would still subtract 8.1 minus 4.6. I would still have 3.5, but this time there were more negatives, so our answer would be negative 3.5. What if they were the same sign? Same sign means instead of canceling, we would combine them. Add 8.1 plus 4.6 to get 12.7, and so this would be negative 12.7. Okay, and if they were both positive, then I would still get same sign combined, but this time the 12.7 would be positive. Okay, opposite signs, a little more complicated where we cancel. Same sign, easy. You just combine them, add them, and keep the sign. They're going to also kick it up a little bit with some of our, mixed numbers and our order of operations. So this one just has kind of a lot of parentheses going on. When I do the parentheses, start on the inside. Here's a set of parentheses. Here's a set of parentheses. Brackets are like parentheses. The furthermost on the inside would be this negative 8 plus 6. So that's what we would do first. Start on the inside. Start with the grouping on the inside. Negative 8 plus 6. Opposite sign means we cancel. To what though? Well, we had more negatives. What do I do with the question? Bring the rest down. What can I do now? Well, inside, now we're kind of done with that set of parentheses. So we still got to work with what's inside these parentheses. Negative 4 plus negative 2. Same sign. If I owe you 4 and I owe you 2, I don't all of a sudden owe you, right? I don't owe you 2. I don't all of a sudden have to. They combine. Same sign, combine to make negative 6. And last but not least, negative 9 plus negative 6, same sign, combine to make negative 15.
So we will have our order of operations from prior. Just I don't even think it's as hard with some of the stuff. We're just now going to be adding integers, all those positive and negatives. Last but not least, they are going to have a couple word questions with these. You need to know whether these mean positive or negative. If I gain 3 yards, if I lose 12 yards and I gain 13 yards. So we're watching a football game, right? We watched 3 plays. They gained 3 yards. They then lost 12 yards. They then gained 13 yards. Where are they at? Mathematically, what has happened, right? Well, gaining 3 yards, you need to know that gaining means that those 3 yards are what? Positive or negative? Gaining positive yardage, right? But then they lose. That means that they get pushed back 12 yards. So now that's going to be, what if they then gain 13? So now they push it back the other way. So the question again, what's happened? What's happened over these 3 plays? Well, I can find that out by combining 3 plus negative 12 plus 13. And there are 2 ways to do this. What a lot of us are going to do, if you're comfortable with kind of the previous section, is you're just going to go from left to right. And so you're going to do 3 plus negative 12. I got 3 positives, 12 negatives. Combine or cancel. I hope you know by now. Opposite signs cancel. So I do. 12 minus 3 is 9. But 9 what? More negatives. Plus 13. Opposite sign. They're going to cancel. I'm going to do 13, cancel out 9, leaves me with 4. 4 what? What do we have more of? This time we had more positives. So this will be an overall change in 3 plays of positive 4 yards. If I gain 3, I lose 12, and I gain 13, I've got a total of 4 yards positive. This could be money too. It could be $3, $12. You know, if I gain $3, I lose $12, I gain 13, I'm up $4, right? It doesn't have to be football if you don't like that. One more option. And this we're going to, and I'm not saying this, if this doesn't make sense to you yet, don't stress out about it, but there's going to be a property we talked about in addition where I can redo the order. So if everything that's happening in here is adding, I can actually combine just the positives with the positives. I can add in any order. The only thing happening in this math problem is adding. So I can add the 3 and the 13. Same side combines to give me 16. Then bring down the plus negative 12. Opposite signs cancel. 16 minus 12 would be still positive 4. So if that bothers you, don't do it that way. We'll talk about that more later. But I want you to know that if that's something you do know how to do, you can feel free to do that in these questions. So that should be it for 1.4. Go ahead and keep working on the homework, and I will see you guys soon.